Alright, today I want to talk a little bit about mountain building. As always, you can follow along with the notes here, along with the PowerPoint that I gave in class. Alright, so orogenesis is the process that produces a mountain belt, and deformation is all changes in the original shape or size of a rock body. You can place those in there. So stress is the force per unit area acting on a solid. So how much stress is it under? Is that force that's acting on it? And strain is the change of the shape or volume of a body of rock as a result of stress. And those are your top four up here. So factors that affect rock deformation. Temperature and pressure is one. So brittle deformation is fraction of an object once its strength has been exceeded. And ductile deformation produces a change in the size and shape of an object without fracturing or breaking the object. So rock type has an effect on deformation. So mineral compositions and textures of a rock also greatly affect how it will form. Okay, and time. Forces that are unable to deform rock when first applied may cause rock to flow if the force is maintained over a long period of time. So the longer it's under stress, the greater the chance that it will cause deformation. Okay, so there's three types of stresses. There's tensional stress, compressional stress, and shear stress that result from these three different types of plate boundaries here. Let me move up here. So tensional stress occurs at a divergent boundary because it's being pulled apart, compressional at a convergent because it's being pushed together, and shear at a transform because it's being slid past one another. All right, let's get into types of folds here. We have anticlines, which are most commonly formed by the upfolding or arching of rock. So the anticline here, and the synclines are linear downfolds in sedimentary strata. You can see that here. We have monoclines, which are large step-like folds in otherwise horizontal strata. You can see a great picture of a monocline here. When we get to the four types of faults here, we have a normal fault, a reverse fault, a thrust fault, and a strike slip fault. Okay, a normal fault is a hanging wall block moves down relative to the footwall, so it moves down this way. A reverse fault is the hanging wall block moves up in relation to the footwall block. We have a thrust fault, which dips at less than 45 degrees here. And strike slip is when they move past one another. Normal fault. Okay, once again, same types here. We also have a joint, which is a fracture along which no appreciable movement has occurred. Okay, let's get to the types of mountains. So mountains are classified by the dominant processes that form them. Okay, so folded mountains, you have mountains that are formed primarily due to folding. Fault block mountains are formed as large blocks of crust are uplifted and tilted along normal faults. You have gravens, which are formed by the downward displacement of fault-bounded blocks, and horsts, which are elongated and uplifted blocks of crust caused by faults. We have domes and basins, which are upwarding produces of a circular elongated structure. So a dome, that upward structure, and a basin, a downward structure there. And then uplifted mountains are circular or elongated structures formed by the uplifting of the underlying basement rock. So just pushed by uplifting there. So getting into mountain formation. So most mountain building occurs at convergent plate boundaries because they're being pushed together and forced upwards. But colliding plates provide the compressional forces that fold, fault, and metamorphize thick layers of sediment deposited at the edges of land masses. So an ocean-to-ocean convergent plate produces volcanic-type mountains. Ocean to continental convergence is going to produce volcanic mountains and folded mountains. Continental to continental convergence is pretty much we've already talked about the collision between two continental plates, and the fragments will result in folded mountains. So once again, divergent plate boundary is going to result in those fault block mountains. We can talk about mountain building by continental accretion as well. Let me move my face out of the way here. Continental accretion is the process that occurs when crustal fragments collide with one another and stay connected at a continental plate. And we get terranes, which is any crustal fragment that has a geological history distinct from that of the adjoining fragments, so a different geologic history than what they're attached to. And not all mountains are formed by plate boundaries. Some are formed by hotspots or regional extensions or stretching. So think of the mountains of Hawaii here. Once again, we come to this concept of isostasy, which is that Earth is floating and in a gravitational balance on that liquid mantle portion. All right, that's it for these notes. Thank you.